Okay, ready or not, here we go. So, our starter questions. This is a review now for the polar test, and this is in polar. And here's where it is. You know how big of a deal I have said drawing a triangle is. Or I think even though this is a dot, I would make the triangle that goes to it to remind yourself where it is. Because then you can also do things like change it into rectangular. All right, but I didn't ask for that. I asked for 3 other names for it. So if this is 2, but why is it -2? And what's going on here? The kid at this point is confused. And why would the kid be confused? Because they're getting it wrong. That's not where it is. So at least hopefully you can figure out where it's supposed to be. Tommy, give me directions on where to go from here to get it in the right spot.
You would reflect it over the middle.
All right. Yes, I'd like to say over the origin. Up to there. And then I draw myself another triangle here with this being 2. And then which one is it? The red dot or the black dot? It's the red dot. This is where this point is. And then once I saw it there, you're going to have a much less chance that you'd mess up where you were. Okay, so if you're right there, what's another way to get there? Well, here's a rectangular way to get there. Do you recognize this? It's the 1, 2, square root of 3 triangle. So one point you could have said was square root of 3, 1. These directions didn't say it had to be in polar. Okay. If they asked for rectangular, how many of you think you could have gotten the root 3 over, 1? Raise your hand if you would have been comfortable with that. Okay, good. Now, another way to get there is to say, oh, that's the same as pi over 6. Couldn't we have just said 2, pi over 6? Yup. That's another one of the ways to get there. Another way to get there would be to say 2, and then use a negative angle, which would be a whole bunch of pi over 6s. I'd use negative. 6 pi over 6 just gets you to the other side. 79 to 11, 12 would be too far, so 11 pi over 6. And there's a whole bunch of other ways. Let's give one more negative way to say it. We could say -2, some other angle than 7 pi over 6. We could say that it's -2 with a, let me think, -1, and then negatives. I feel like I want to say negative pi, but that can't be right. Who had another answer with the -2? Help me, save me. Ray?
-2, -5 pi over 6.
That's it, 5 pi over 6. Okay, and there were a lot of different answers that could have worked. You could have also added 2 pi or -2 pi to those angles. All right, now 3 points on this. I hope you picked 0 as a logical angle. You didn't have to, but that would have been a logical one to pick. So then you're doing cosine of 0. Right away, I want this thing up because the quadrantals come up a lot. This is 1, 0, 0, 1, -1, 0, and 0, -1. And then the r here is r equals, and so I got to figure out cosine of 0 first. Cosine of 0, cosine is the x, and the x at angle 0 is right there. That's a 1. So 2 plus 2 times 1. And that's 2 plus 2, which is 4. Raise your hand if you had 0, 4. Awesome. And those of you that aren't raising your hand, it makes me look like you don't know how to do it. So please, when I say raise your hand, I know it's a task, but if you actually had it right, please do raise your hand. And if you didn't, please don't raise your hand. Because if everybody just raises their hand like they think they get it, but they really don't, then I'm not going to like stop and talk about it. All right, but if people half the class doesn't raise their hand, that sort of indicates that, gee, we better do another one like this, when maybe you were just being too lazy to raise your hand. All right, so I'm just encouraging you to please do follow that direction. All right, here's another one. If you wanted to choose pi over 2, it's another one of these quadrantals, and they're easy to find. So cosine is the x of it, so that'd be 0. Then I go 2 plus 2 times 0, which should just be 2. Pi over 2 and 2. Yes?
When we write the points, should we...
Technically, it's 2 comma pi over 2. And I can conflicted about this because one of my colleagues really likes to do the charts the other way. But when you're writing your points, you should write r comma theta. That is the standard thing that everybody across the country always writes them r first. So these are just a table because we get to pick the thetas. All right, so the third one. Well, you can pick anything you want. I personally am going to choose not a quadrantal this time. I'm going to choose 3 pi over 4. You totally might not have done that one, but if I put 3 pi over 4 in here, it would be like this, and I got to do cosine on, if that's a 45-degree angle, then I know this is the 1 square root of 2, and oh, don't forget this is negative, and then I can do cosine as adjacent over hypotenuse, which is negative 1 over root 2. So I'm going to put that in 2 plus 2 times, and that cosine again was negative 1 over square root 2. Now that's a little bit gross. I wish somebody would have made me memorize square root of 2. How many of you actually used this and put 1.4 right there? Okay, so nobody remembered it was 1.4, or am I making a mistake? I could be either one.
Yeah.
Okay, so you can have, if they ask for exact answers, you can use 2 plus 2 over root 2. But if you had to actually graph that point, you have to kind of know about where that is. All right, so then you'd go 2 over about 1.4, which then I would go, oh, that's pretty much it's pretty much 2 over 1. It's actually closer to 2 over 1 than 2 over 2. So that's between 2 and, what if it had been 1.9 or something? Then it would have been 1. So it's between 1 and 2. So I'm adding 2 plus something between 1 and 2. So it's like maybe 1.5. So maybe about 3.5-ish. And again, I know I'm off, and it's okay. But I know that it's between 3 and 4 at least. Okay. So you have to be able to estimate these. So don't forget that whole, like, square root of 2 is 1.4. What's the square root of 3 about? 1.7. So that you can estimate, so that you can put a dot on the graph in the right spot. This is totally fine for putting in your chart, but how are you going to put a dot on the chart if you don't have any clue what the square root of 2 is? Okay. Now there's so much more to know for this test. I want to open it up and give you a chance to ask questions. Is there a certain type of question that you are concerned about for this upcoming test? We did conversions between rectangular and polar points and also equations. We also graphed polar. We also found intersection points between polars. We've done all of those, and you had a little quiz that we did on Friday, and you graded it yourself. And maybe if there's one of those quiz questions that you want me to go over, is there anything? I'll pause for a second while you think. So by asking the kids to look at their little practice quiz we did on Friday, I determined that the one that seems like it's giving people the most trouble was converting. So I'm going to give you one of those. We'll start off with a nice softball. X squared plus y squared divided by y is equal to, let me think, x. Would you please convert that over to polar? Okay, fundamental to understanding these was a little drawing. I'm going to make this little drawing. X, y, r, and theta. Would you please try to come up with all 6 things that I told you to know for this coming test? These are facts that can help you convert between polar and rectangular. All right, Tommy, give me one of them.
X squared plus y squared equals r squared.
Excellent. Now call on somebody else in the class to give me another one. R cosine theta. Call on somebody else. Nice. Call on somebody else. I know at some point you could be like, I don't know anybody. Lita, you got called upon. Know any? Inverse tan of. Close. Just the fraction. Y over x is equal to what? Yep. And another way to write that one, Evie. Yep. 1, 2, 3, 4, 5. We got 5 things. Who remembers what the 6th handy thing was? It's a derivative of one of the ones we have on the board. Ray, which one's left?
R equals plus or minus square root of x squared plus y squared.
Nice. All right, so there are 6 handy conversion statements so that when you're doing a problem like we're doing right here, you've got those all pulled up from your brain and maybe even written down on your test. You don't have to, but you know, if you're stuck on one, I mean, it might be smart. Pull up all the things you know and just set them on the table. Oh, so this one is right here, and this one is right here. So this is r squared over r sine theta is equal to x, which is really r cosine theta. Now, can you cancel in something like this, an r squared over an r? Absolutely. Math keeps working just because you happen to be changing between systems. Okay, so it's r over sine theta is equal to r cosine theta. And do I have to actually solve it for something? Well, sometimes you do. But unless they tell you to, you don't have to. In this case, I'm telling you to. Solve for r. Now, I know some of you are going to have some pain on this because you're like, no, I don't know how to do that. I'll give you only this hint. You have all the tools that you need. You can do this. Okay, so here's a thought. You're sitting there stuck on the test and you're like, trying to solve for something. There must be some way to solve it because it says to solve. Well, when there's a whole bunch of really smart kids stuck on one problem, it usually means if you can factor it, you should. And yeah, you should factor it. Well, how are you supposed to factor it? They're on opposite sides. Well, then get them on the same side. So I'm going to subtract r cosine theta from both sides. And now I have r over sine theta minus r cosine theta is equal to 0. Ooh, it's set equal to 0. And then I can maybe factor it? Yes, you can. Look at those r's. There's an r in both of them. R comes out. What you got left? 1 over sine theta minus cosine theta equals 0. And r is almost alone. What do I do to get r alone? Divide both sides by 1 over sine theta minus cosine theta. 1 over sine theta. I could just start saying cosecant because that's the same as 1 over sine, but minus cosine theta. And, well, that's weird. This tests you whether you know that this is 0 or undefined. What is it? 0. So I asked you to solve for r, and r would be equal to 0. Huh. So if r equals 0, then cool. That's one of the solutions to the system of equations. Could there be other solutions? Yeah, let's not. It's going to get super complicated. But my point was, you could solve it sometimes. And how many of you, be honest, how many of you forgot that, we'll put it this way. You might have known that you could factor, but you didn't see that you could factor. Raise your hand if you didn't see that it could factor. All right. But do you get at that moment? That's what you're supposed to be thinking about. Banged on this drum all year long. If you get stuck, often it comes down to if you can factor it, you should. And then to get things factored, you usually want to set them equal to 0. That's kind of the other part that goes with that. Okay. What else is there? Well, I had a student ask about this, and I definitely wanted to practice it. Lita, can you shut the door for us? Getting a little loud out there. And that's the intersecting thing. If r equals 1 and r equals cosine of theta, we'll just keep it super simple. How do you do this again? How do you do intersection points? Aiden, give me a basic reminder. Okay. So exactly what would I write right now? Yeah. I'm going to put it right here, r equals 1. So I'm going to say 1 equals cosine theta. And yes, I like to say that this way normally. Cosine theta equals 1. That sounds like a circle trig question. Like I can get 2 answers for that. Is it possible there might be 2 answers for this? Yeah. In fact, if you think about what it looks like, this sometimes helps. Do you remember that r equals 1 is a circle with a radius of 1? And do you remember that cosine theta kind of is over here? Do you get that's pretty much probably going to intersect? And if I had moved that circle over, it would have only intersected once. But in this case, looks like it intersects twice. And I wonder if it's going to actually be in the same 2 quadrants as what I do for circle trig. Yes, it is. Look at that. I know there's a couple people that have to go take that AP test. Go ahead. Good luck. All right, so let's find those 2 angles. Cosine is adjacent over hypotenuse. This must be, wait a minute. Oh, you can't make a triangle where the hypotenuse is the same size as the other side. So this must be one of those quadrantals, actually. All right, so let's see. Cosine is 1 means that the x is 1. That's a spot where x equals 1. Dang, maybe there's only one answer to this. Do you actually get that there is only one answer to this? And I think some of you are sitting there thinking, yeah, he's going to eventually figure it out. That if you make the circle with a radius of 1, it actually touches right there. So it's the red one and the green one. They only touch once. It's not the blue one and the red one. I only figured that out because I went and looked for my answers of cosine of theta equals 1. And there's only one spot where x, cosine is like x, right? Where x equals 1, and it's that, which is at 0. So in the end, my angle answer is 0. But if you just put 0, I'm going to cry a little bit and mark it wrong. Tommy Demand, final answer. In r comma theta form. 1 for the r, 0 for the angle, 1 comma 0. Do you get that that's a polar point? All right. Okay, so that's an example of an intersection. There's a lot of things that you need to know how to do. There's also a lot of practice problems in this file. And I think at this point, I feel like I've done enough that you should be ready. There's only one last thing I want to remind you of, and that's that I told you circle trig was going to keep coming back. There was one more part of circle trig, and that's where you actually have the graphs. And I want to remind you about this. Actually, let's make one that goes like this. if I said that this spot right here was at 2 comma 5, and I said that this spot right here was at 6 comma negative 7, would you know how to write the sinusoidal for this? Hint, starts with y equals cosine. And yes, there's something in front of it. And you might want to find that midline that runs down the middle. Everybody take a minute and refresh your memory on this. This is part of that circle trig stuff. I'll pause for a second while you try this one. So I'm starting the recording because you're making sense. You said that we should find the midline to start this by finding the average of the 5 and the negative 7. How do you do that? Add together, divide by 2, and you end up with add them together, I get negative 2, and then I divide by 2, and I get what? Negative 1. Raise your hand if your midline was correctly going through negative 1. All right, awesome. Most people seem to have their hands up there. I get why you might have thought negative 2. If you just quick added them together and thought you were done, but remember, averaging is adding them together and dividing by how many numbers there were. Okay, so the midline's at negative 1. Does that mean there's a negative 1 in the front? No. Tommy, tell me what that means. The negative 1 tells me something. You are correct. There's a shift at the end. The midline is the shift at the end. Now we still have a bunch of little parts left. Bertchild, can you tell me one of them? Excellent. Amplitude, usually we make a little line like this that goes from the middle line all the way up. And how far would that be? And I'm looking at the y values. And so negative 1 compared to 5. And then, yeah, I agree. It's 6. So there's a 6 in front of the cosine. Raise your hand if you had a 6 there. Okay, good. Aiden, tell me more.
You can take the distance from the midline, from the center to the first highest point.
Okay, so that's this distance right here, which is the x value of that first peak, which is what? 2. So the 2 goes here. And there's always a theta or an x right there. And so there's only one thing left, and there's a formula for it. Ishi, what's the formula for that? Oh, wait. Comment? Good question. No, it's not. This is a shift to the right of 2. Think of it this way. This peak, if this was really cosine, has been shifted to the right. And so therefore this should be a minus 2. And if you're really not sure I'm right at the end, take the answer I get, type it into Desmos, and I think you'll see that it is correct. So far I'm correct anyway. At least I think I am. Okay, and then let's do one more. Grace Wander. There's a formula for this part right here. Do you remember it? Period equals, don't forget that side, 2 pi over b. Is it always 2 pi? Yes, unless they change the function to what? What function does not use 2 pi? Tangent. Okay, this was a cosine, so we were good. I'm just reminding you, if it's a tangent, you'd have to use pi. All right, so we got period is 2 pi over b. Did they tell us the period or the b? Well, we don't know the b, so we must know the period. So the period goes from this 2 to this 6, and that takes 4, so the period's 4. True or false? Period is not 4. If you thought the period is 4, I get why you'd think that, but that's just from a high to a low. You got to get back up to the high spot again. So the period is 4 plus another 4 makes 8. So 8's the period equals 2 pi over b. Flip-flop the b and the 8, and you get b equals 2 pi over 8. And that's b equals pi over 4. Raise your hand if you had pi over 4. Awesome. All right. I'm choosing to remind you of that versus regular circle trig right now. You have to know that too, but we practice that in the midst of other problems. Anything else that you want to ask me? All right, so here's what I'd like to do. You've got an assignment with a key, and I strongly recommend this is the part where you should work on your assignment that's got a key and do some problems, act like it's a test. For some of you, I know right now it'll be hard to get motivated to do that, but this literally can be the test that makes the difference. For some of you, you're in that A- zone. It's a very common zone to be in, and it's also a dangerous zone. Because if you get a B on this next test, guess what that does? It brings your A- down. If you get a regular straight A on your A, and to add that to your A-, it brings it up a little bit, maybe even all the way to the A's. My point is all it'll take on this test is one more question right, and you would get a whole difference in grade between a B and an A. And the extra practice is what's going to make that difference. Okay? You really want to be the A student? This is that moment. All right, that's all I have for the video for today. Test is tomorrow.